Okay, y'all. Today, the magic number is 3. You have 3 more videos left of PreCalc. 3. You can do it. Keep that number in your head, and then it's almost done from here. Okay? This is going to be easy stuff. Arithmetic sequences and series. What is a sequence? Do you remember what a sequence is? You know what sequences are, okay? So probably your most famous sequence would be, something like 5, 10, 15, 20, et cetera, okay? What are you doing here? You keep adding 5 the entire time. So there's what we call some kind of common difference, whether we're adding or we're taking away, we're adding a negative. So this is the formula to find the nth term of an arithmetic sequence. Arithmetic is when you add or subtract the same number. And it would be a sub n equals a sub 1 plus n minus 1 times d. Now let me explain what these new symbols are. You should have seen them before. This a sub 1 is the first term in your sequence. First term in your sequence. Okay, so in this case, this was a 5. So this would be a 5 right here, whatever your first term in the sequence is. D would be what your common difference is. Common difference. So again, we're going by 5s. The common difference would be 5. And then you would write n minus 1 to find the nth term. So let's say I wanted to find the 100th term. So you'd write a sub 100 would equal your first term plus 100 minus 1 times 5. And you could find the 1000th term. So it's a very nice, easy, quick formula to help you find those terms. My pink pen looks a little too light. I'm going to have to move to like a purple pen or something. So let's do an example of this. Find the 12th term of the sequence 9, 16, 23, and 30. Okay, so what do we really need? We need our first term. We need to know what n is. Again, looking up at this formula, and we need to know what d is, our common difference. Okay, so our first term, it's easy. It's 9, right there. What's the common difference? What am I going up by? Looks like I'm going up by 7. And what's my n? Well, n is the position of the term that you want. You want to know the 12th term, so that's your n. So your a sub 12, your number in the 12th position would be a sub 1 plus n minus 1 times d. So that would be a sub 1, which is 9, plus 12 minus 1 times 7. And that would give you 86. So 86 is the 12th term. Rather than writing it all out, oh, let me keep counting 7, oh, 37, oh, 42, 44, whatever. Don't do that, please. If I said find the 100th term, I don't want to see 100 things listed out. I just want you to be able to, use this formula. So that's your first example. Let's look at our next example where we have to write an equation for the nth term. Write an equation. Okay, so anytime it says write an equation, you want to you want some n's in the equation. You want an n in the equation. Okay, so we want to write an equation for the nth term in the sequence 5, negative 13, negative 31. So we still want our a1, which is 5. Our n, well, we want our n to be open, so we're going to leave it and we'll call it n. And our common difference would be, well, let's see, to go from 5 to negative 13, we'd have to subtract 18, right? Subtract 18, so negative 18 would be the common difference. So when we go to write the formula, again, a sub n equals a sub 1 plus n minus 1 times d. You would have a sub n equals the first term, 5, plus, leave your n as n, minus 1 times negative 18. Don't just write minus, it looks like minus 18, so put it in its own parenthesis. distribute this out. 5 plus negative 18n plus 18. And running out of room, let me go over here. A sub n equals 23, right? 5 and 18 make 23 minus 18n. So there's a formula, there's an equation for our nth term of this sequence. So if I wanted to find the 100th term, I could put 100 right here times 18, negative 18, and then add 23 to it. Okay? Easy peasy. Next, write an equation given a sub 5 equals 19 and d equals 6. Interesting. Okay? So we have a problem here. In order to write an equation, we need to know what A1 is. We don't know what that is right now. And we have to leave n as n. And the only thing we know right now is d is 6. So what could we do? Well, we're going to first find out what A1 is. We need to know what A1 is. Okay? So first thing is find out your A1. You should always try to find that first position. Again, what does this mean? This means that you have in the 5th position is the number 19. So 1, 2, 3, 4, 5. And that position is the number 19. Now, you could work backwards. But what if I said the 50th position was 19? Then that would be really, really annoying to work backwards. So that's why I understand that many of you will probably be like, well, I'm just going to keep subtracting 6. Well, let me show you a way to find A1, though. Okay, let's just use the formula to find A1. Again, here's our formula. A sub n equals A sub 1 plus n minus 1 times d. If I know this, that A sub 5 is 19, if I know the 5th term is 19, so if I put A sub 5 here, and I call it 19, and I leave A1 open, because again, that's what I'm trying to find. What would my n be? What would my n be? My n would be 5. So 5 minus 1 is 4. And then d is 6. So 4 times 6 is 24. Hold on one second. And then you get negative 5 equals A1. Okay. Okay, so see how we use the formula to get A sub 1, which is negative 5. And again, yes, you could have just, well, can I just keep subtracting? But again, if this was A50, that would just be impossible. Don't, use the formula. Don't try to go like, oh, I'm going to subtract 6 50 times. Look, don't do that. All right, so once we got this, now step 2, we can actually write the formula like we did above. Or write the equation. So again, using that formula, A sub n equals A sub 1, which we now know to be negative 5, plus keep n open, because we're trying to write it for any term, n being any term, and our common difference is 6. And now distribute and combine your like terms. So 6n minus 6, so 6n, what is that, minus 11? Did I write it wrong here? I think I wrote it wrong. I wrote it wrong on my example there. All right, pretty easy peasy. All right, now we're going to talk about a series. And I need you to pay attention, especially my calcers, my people going to calculus. So a series is when you take the sequence and you add up all those numbers. Okay, we call it a series. So if I take my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I add them all up together. Well, there's going to be this new notation they're going to give to you. This is important notation, especially for next year in calculus. So let me explain what this notation is. This is sigma, Mr. Good Old Sigma, and sigma means sum. Okay, it's not some kind of sorority, fraternity, or whatever. It's means sum in mathematics. So when you see that, you're summing something, you're adding things together. You're adding particularly some kind of function right here. This is a function representing k. This is a formula for the terms in your sequence, okay? K equals 1 would be the first value that you plug into the formula. Not necessarily plug into formula. This is not the first value in the sequence. This is what you plug into the formula to get that first position, okay? And then n would be the last value you plug into the formula. Oop, there we go. All right, so before we actually do sum them, let's work on this notation. So if I give you the sum of 4k plus 2 from 1 through 12, what this means is the following. That you have to plug 1 into this formula. What would 1 times 4 plus 2 be? That would be 6. This would be the first term in your sequence. And then you're going to add that to, then you would plug in 2, then you would plug in 3, then you would plug in 4, all the way up. So if we plugged in 2, let's just do 2. That would be 10. And we keep going and going and going until we go to 12. That would be our last value that we plug in, which is our last number here. So if I plug 12 in, 12 times 4 is 48 plus 2 is 50. This is my last term in my sequence, my AN. Okay? Now you would have to add all those up. So how could we do this quickly? Well, we have formulas to sum things, okay? There's actually 2 formulas. They're the same. It just depends on what they give you is the one that you want to choose. So write this down. S sub n means the sum of your 12 things. You could do n times a sub 1 plus a sub n over 2, or you could do n over 2 times 2 a sub 1 plus n minus 1 times t. Again, which one would you? I probably prefer to use this one. I mean, this one seems simpler, but depending on what they give me, I might use this. If they give me an n, I might use this one. So let's just see, like, for example, what would this one up here that we just did, what would the sum actually be? So S sub n would be n, which in this case, how many n things are we adding? Well, 1 through 12 is 12 things. So n is 12 times, and again, I'm using this formula. My a sub 1 is 6, my first position. My last position is 50, and I divide that by 2. And 6 plus 50 divided by 2 times 12 is 336. So the sum, this right here, is actually 336. Okay, so it's kind of like using 2 formulas at once. So we're going to do one more problem here, and this is actually question number 12 on your homework tonight. Woohoo! You are to find the sum when k is 4 through 10 of 2k plus 1. Okay, so here's what I would do first. I want to get what that first number is, that a sub 1 is. So I'm going to plug 4 in, and I would get 4 times 2 plus 1 is 9. And you could do another one if you want to. You find a common difference, you could, but what would come after 4 would be 5. 5 times 2 is 10 plus 1 is 11, and so on. And then you got to get that last one, that last number. 2 times 10 is 20 plus 1 is 21. Okay, so first number, last number. Now, here's the question. Again, it's up to you, whichever formula you want to use. This is the one I like to use the most. S sub n equals n times a1 plus an over 2. Okay, a1, we got it. An, the last number, we got it. What's our n? What's n going to be? Oh, n is 10? No, 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 no. No, 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 no. N things. We're going from plugging in a 4 to plugging in 10. So how many of those numbers is there? And a lot of students say 6. No, no. 4 to 10. Okay, watch my fingers. You plug in 4, 5, 6, 7, 8, 9, 10. You've plugged in 7 things. So your n is 7. Don't just think, oh, I can subtract this, because then you're not counting that first thing you plugged in. Does that make sense? So there's 7 things that I plugged in. This is my A1. This is my AN. I'm just going to plug this in. 9 plus 21 divided by 2. And I get, whatever that, 15 times 7. 15 times 7. I can miss this out, I think. 105, is that right? Yes. 15 times 7, 105. All right. So you're going to try your homework tonight, which looks like this. It's called homework 1. You're going to only do 1 through 16. I just did number 12. Okay, so be careful. Some of these go from 3 to 8. That's not 5. That's 6 things. 1 to 101, though, is 101 things, because you're counting 1, 2, 3, 4, 5. Okay, but when you start at 3, you have to count that. And that'll be good. That'll be it for tonight. All right. Enjoy. Bye-bye.